Hi everyone, this is Pre-Algebra, lesson 5-5. We're more than halfway done with this topic. Factoring expressions. In this lesson, we'll be able to use common factors and the distributive property to factor expressions. Let's look at explain it. Tasha is packing gift bags that include the same items. She has 72 glow sticks, 36 markers, and 24 bottles of bubbles. Tasha believes that she can pack no more than 6 bags using all of her supplies. How can you use what you know about common factors to solve the problem? So what's the problem here? She's packing gift bags and she has limited items, right? She can pack no more than 6 bags using all of her supplies. Is that true? We have to compare the numbers using the factors, okay? So critique reasoning. Do you agree with Tasha? Yes or no? And explain why. So here, what are we trying to get? After trying to figure out the factors, what are we trying to get? We're trying to fill them in bags, right? So 72 has factors of 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Okay. What about factors of 36? Factors of 36 would be 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, so all these numbers can be multiplied with another number to make 36. What about 24? The numbers that could divide 24 would be 1, 2, 3, 4, 6, 8, 12, and 24. There you go. So then why do we need to know all the factors? See if there are any same factors that you see. We got 1, 2, 3, 4, 6, no 8, 12, not 24. We have not 18, not 36. So the greatest common factor, GCF, is 24, right? So for all of them is 24. But greatest common factor for 24 and 36 would be GCF of 24 and 24 and 36 would be 12, right? That would be the greatest common factor. Wait, it's not 24. It would be 12. Right? 12, 12, 12. And greatest common factor for 72, GCF of 72 and 36 would be 18. And then GCF of 72 and 24 would be 24. Okay, so they have different greatest common factors when you have different pairs, but all together, their greatest common factor altogether is 12. Right? So So you can say that, no, actually, she can maybe make more bags than that. She can make 12 bags with all of her supplies. Right? So you can say, no, their greatest common factor is 12. So she can make 12 bags of the same number of supplies. Okay, if Tasha creates the greatest number of gift bags, how many of each item is in each bag? Explain how you know. So you want to find how many of each item would she put in one bag each, okay? Each item. So let's figure out glow sticks first. You have 72 glow sticks, right? So, oh wait. So glow sticks would be 72 divided by 12. You divide what you have equally into 12 bags. So you divide it by 12. And that should be how many? 6? Yes, 6 glow sticks. And what about the next one? Markers. Markers. You have 36 markers total divided by 12. That should be 3 markers. And what's the last one? Bottles of bubbles. So you had 24 bottles of bubbles. So 24 divided by 12 is 2 bottles of bubbles. So in total, for each bag, she will put in 6 glow sticks, 3 markers, and 2 bottles of bubbles. Okay, there you go. So focus on math practices. Tasha added more markers and now has a total of 48 markers. Does this change the possible number of gift bags? Explain. So instead of having 36 markers, would 48 change her number? Well, let's see. We have the same number of glow sticks, 72 glow sticks, and then now 48 markers, and then 24 bubbles. So basically, is their GCF still going to be 12, or could it is it different? Okay. So figure out the GCF for all 3 of them. Put the factors for 48 and see what's the best. 48 has 24 as a factor, and 24 would be the factor that could divide all of them, right? So GCF actually changes to 24. So now instead of making 12 bags, now she can double that amount and make 24 bags. So yes, this changes the possible number of gift bags because the greatest common factor of 72, 48, and 24 is 24. There would be how many bags? 24 gift bags. Okay. So let's move on to example 1. Think about how the distributive property relates to factoring expressions. We ended our last lesson with distributive property. Let's think about factoring expressions. Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, okay? And a different sized can that covered 12 square meters. So they're talking about if it's a square meter, it's area, okay? What are possible length and height dimensions of Kiana's mural? The expression 3x plus 12 represents the area of the mural. Why? Because she used 3 cans of paint. And so that's going to cover X square meters. And then she used a different size can to cover 12 square meters. If you add them up together, you don't know how many cans of paint she used for covering X square meters, right? So 3 times X, using 3 cans of paint, you don't know the area that it covered, but 3x plus 12 would be the area that she covered total in this situation. So you can use an area model to represent the area of the mural. And so one possible set of dimensions would be X plus 4 meters long and 3 meters tall. And it doesn't have to be all numbers. If you don't know and they don't give you enough information, then that's okay. Your answer could be, could have variables. It could be expressions, okay? So in this situation, you can have X plus 4 as a length and 3 as a width. So that would be your answer. Another way, you can use common factor. 3x plus 12, you can use distributive property backwards and say, oh, the coefficients will have 3 as greatest common factor. And I'm gonna factor that out and use parentheses to write another equivalent expression. So 3 times x plus 4 would be equivalent as 3x plus 12. And so you can say 3 times x plus 4 would be the width and the length, which will equal the area. Okay, so there are 2 ways to solve this problem. You can pick your own way, but please answer this triad using the diagram and filling in the blanks. Use factoring to write an expression for the length of the pool with the given width. So can you use the distributive property backwards using factors, greatest common factor, to write an equivalent expression? What's greatest common factor for 4 and 20? 4 divides them both. So you can pull out 4 and then say 4x divided by 4 is just x. 20 divided by 4 is 5. So 4 times x is 4x. 4 times 5 is 20. Right? So the length of the pool, because the width is 4 meters, you're multiplying x plus 5, right? So the length of the pool is x plus 5. And your length could be expression. Convince me, how can you use the distributive property to check the factored expression? Use the factored expression for example 1 in your explanation. So this is using distributive property backwards by using factoring, but you can check if your answer is right by using the distributive property to expand the factored expression. So if they're not equivalent, then you did something wrong, right? So try to expand. You can use it to expand the expression. Dot, dot, just like this. 4 times x plus 5 is equal to 4x plus 4 times 5, which is 4x plus 20. And they are equivalent. So they're the same. okay? All right, example 2, factor expressions with negative coefficients. Rodrigo and Jordan each factor the expression negative 2x minus 6. Who factored the expression correctly? So here we can see that Rodrigo uses a positive common factor 2 to factor the expression. 2 is a common factor of negative 2x and negative 6. And so he factored out 2 and got negative x minus 3, which will equal to negative 2x minus 6 if you expand it. So they should be equivalent expressions, right? So check. Jordan uses a negative common factor, negative 2, to factor the expression because they both have negative. So he factored out the negative as well with the 2 and said in the parentheses, it should be x plus 3 left. Which of them are correct? Is correct. They're both equivalent expressions, right? This is check, that's check. If you expand them, they're equivalent expressions. So both of them are correct. So there are 2 ways to factor expressions with negative coefficients. Okay, this is one way, this is another way. So let's see if you can factor negative expressions in 2 ways. Show 2 different ways to factor this. Okay, one Rodrigo way, another one should be a Jordan way. Okay, the first one you can factor out the positive number. So 4 and 28 has the greatest common factor of 4. So you should have 4 times negative x minus 7 for Rodrigo's example. And what about Jordan's way? You can factor out negative 4 and say it's going to leave x plus 7 in the parentheses. Okay. All right, example 3, factor 3-term expressions. What if you have 3 terms, not just 2 terms? You still can use greatest common factor for all the coefficients, but it needs to be the greatest common factor for all of them, not just 2. Okay, so make sure you find greatest common factor for 6, negative 18, and negative 12, which is 6. So you can use it to factor the expression with a distributive property. So factor out 6 out. That means you need to divide all the terms with 6. 6x divided by 6 is x. 18 divided by 6 is negative 3. Negative 12 divided by 6 is negative 2. So that should be your equivalent expression for that. So when you factor, you need to change from here to there. Okay, factor. When it says solve or expand, it's the opposite way, from here to here. Okay. So try it. Write an expression for the expression above using a negative factor. So this example used a positive 6. What happens when you factor the expression using negative factor, negative 6? What would you get? 6x. What does 6x become if you divide it by negative 6? It's going to be negative x. So x divided by negative is just negative x. Okay, your sign doesn't matter where it is, as long as you have one negative, it's negative. And if you have 2 negatives together, so like negative divided by negative, they cancel each other out, they're positive. Okay, so that becomes negative x. And then negative 18 divided by negative 6 is going to be, they're canceling out and become a 3. So plus 3, and same way, plus 2y. Okay. All right. So let's summarize our lesson. You're going to use greatest common factor to factor expressions. Okay. So use greatest common factor to factor the number out. When you have a factored expression, you should have GCF times your expression, original expression divided by greatest common factor GCF, okay? So this is factored expression, and this is expanded expression. Expanded, okay? All right, that was lesson 5-5, factoring expressions. We'll continue with lesson 6, adding expressions in the next video. Bye.